Okay, in this flip learning task we're going to be learning about alkanes and different ways to draw them. We'll be learning about full structural formulae and skeletal formulae. By the end of the task you should be able to draw and interpret structural formulae in three different ways: full structural formulae, shortened structural formulae and skeletal formulae. Okay, let's take the alkane propane. So propane is an alkane which has got 3 carbons and 8 hydrogens. So the way that you'll have learnt to draw propane when you were learning your GCSEs is like this. This is, at A level we'll call this a full structural formula. So this shows all of the atoms and all the bonds between them. So let's just take this carbon here. It's got 3 bonds to hydrogens and 1 to another carbon. Now remember the rule that because carbon has 4 outer shell electrons, it can form 4 covalent bonds. So it's formed 1 to this hydrogen, 1 to this hydrogen, 1 to this hydrogen and 1 to this carbon. Now the molecular formula of propane is C3H8. So it's important to remember this term, molecular formula. That simply tells you the number of carbons and the number of hydrogens in the formula. So 3 carbons, 1, 2, 3, and 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. Now you may have seen in GCSE textbooks formulae also written like this. At A level we'll call this a condensed or a shortened structural formula, and the important feature of this is that it doesn't show any bonds and quite useful for writing in text. So here we've got CH3. That CH3 indicates this part of the molecule, and then CH2, that's the carbon and 2 hydrogens in the middle, and then CH3 just here. Okay, let's get technical. So we've learned about molecular formula, full structural formula, and condensed or shortened structural formula. Now this is the one that you won't have learned about before. This is called skeletal or skeletal formula. And the feature of this is that it only shows the carbon-carbon bonds. That's the bonds between the carbon atoms. So here's a skeletal formula for propane. And if we look at the structure over here, the only bonds we're actually going to draw are this one here and this one here. So each line represents a carbon-carbon bond. And this is a very quick way for chemists to communicate chemical structures to each other. So very important to remember, at the end of each line there'll be a carbon atom, so a carbon there, and a carbon there. And the important skill you have to develop is that of recognising the fact that even though we haven't drawn them, there are actually 3 hydrogens on there, 2 hydrogens on there, and 3 hydrogens on there. And after no time at all you'll be looking at sequences of lines on the page and you'll be recognising the alkane structure that it represents. Right, let's just go through a couple of examples. So let's take the hydrocarbon that looks like this, and what I'd like you to do is stop the video and see if you can write out the full structural formula showing all the carbons, all the hydrogens and all the bonds for this alkane. Okay, so you should have drawn it like this. It's got 5 carbons, each of them joined with a carbon-carbon bond. You've got 4 bonds to every carbon, so let's fill up all the gaps with hydrogens. like that, and you've just drawn the structure of pentane. Right, a bit of a challenge for you this time. What about this alkane? Now, this is an alkane which has got a chain and then another group hanging off the side. We call this a substituent. We'll be learning more about this in the next learning video. So stop the video and have a go at drawing out the full structural formula showing all the carbons, all the hydrogens and the bonds. Okay, so we've got in the main chain, we've got 1, 2, 3, 4 carbons. So that's carbon, 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 each joined with a carbon-carbon bond. And then we've also got a carbon-carbon bond just here. So fill in all the hydrogens. We've got 3 hydrogens on here, 2 hydrogens on here, 3 hydrogens on this end, 3 hydrogens just here, and be careful just here. Now you've only got 3 bonds to this carbon at the moment, so that must have 1 extra hydrogen there. Molecular formula C5H12. Later on you'll learn that these two structures are related as what we call isomers, but let's save that for another day.